Hi, my name is Emma Johnson, and my project is a novel way to heat up space using lunar regolith. 50 years after the Apollo landing, the moon is still a major focus for human space travel and habitation among major world leaders. Today, NASA has started to develop a lunar-based program which will allow us to have a leading and viable exploration to build lunar-based camps on the moon's surface. The purpose of my project is to help provide cosmonauts with a solution to conduct space heating on the moon using the moon's most natural resource, lunar regolith. Lunar regolith is composed of oxygen, silicon, and titanium, which are all building blocks to the design of base camps on the moon. My hypothesis for my project is looking at the addition of 550 grams of lunar regolith to a plain solar heater will allow an increase in the temperature to 160 degrees Celsius. My materials for this project were looking at majority of using lunar regolith stimulant, a solar panel, and a DC computer fan. The variables I looked at were my independent variables, which is lunar regolith, solar light intensity, and my dependent variables, such as the temperature of the space heater and the solar panels. For my procedures, it had many steps, which I then was looking at building the frame, which included using plywood and 4 2x2 cut woods to build the frame, as well as some wooden dowels. Once the frame was completely built, as you can see in the photos, I then had to create the input and output flow holes. By doing that, I first had to take the DC computer fan and trace the circumference of the circle, and then I was able to drill out the holes so they were equal sizes in the center of the solar heater. And then once the holes were cut, I was then able to go in with black spray paint and then spray paint the whole inside of the heater black and then allowed that to dry. Once the frame was then dried, I was then able to screw in the fan as well as the vent tube in the back for the output airflow. Once the vent was then put in, I was then able to tear off the protective covering of the plexiglass and glide the plexiglass with the guidelines on the side of it to be secure. Once the glass was in place, I was then able to connect the solar panel to the DC fan, and once I made sure that the fan was moving, I was then able to place a thermal thermometer in the vent tube and check every 5 minutes for a total of 100 trials. Once the trials were in place, I was then able to go back and sew the lunar regolith bags, which included using outdoor fabric and a grommet hole maker. Once I was able to sew the bags in place, I was then able to add 85 grams of lunar regolith to each one and then place it in the heater so that I could test it for every 5 minutes for another 100 trials. My result of my data showed that the 550 grams of lunar regolith to plain solar heater showed that my hypothesis was not accepted because of the fact that my hypothesis was actually doubled the amount that I thought it would. With my hypothesis, I only thought that my data would raise by 10 degrees Celsius when it was actually able to raise 47 degrees Celsius with a high of 260 degrees Fahrenheit. With my chart, data in figure 1 and 2 display all the times that the temperature was collected outside in Celsius and the output temperature of the actual solar heater, which was collected in the intervals of 5 minutes. The highest temperature recorded without lunar regolith was 65.9 degrees Celsius, which translates to only 150.9 degrees Fahrenheit. And I was able to use the equation Celsius times 9 1/4 plus 32, which would equals the Fahrenheit. This is also the figure 2 data, which is still showing you the same thing as explained before. And then this is data figure 3, which actually is showing the results with the lunar regolith, which in the description says that with the included 550 grams of the lunar regolith, showing in the graphs, the output temperature of the lunar regolith doubled the data results, as I mentioned before, within 30 minutes of the previous testing without any additives. Within the 30 minutes, it was showing 48 degrees Celsius, which translates to 118.5 degrees Fahrenheit. And then according to NASA, the moon during the night cycle gets down to 96 degrees Celsius, which is inhabitable for human sustainability. However, according to the data results of my experiment, it can be found that the space heater will increase up to 131.9 degrees Celsius or 269.4 degrees Fahrenheit, concluding that the regolith can increase the moon's surface temperature out of the negatives, which would be a more comfortable living situation on the moon's colonization. These are my bibliographies I used. And for future research, I want to continue this project by looking at the structure of the heater, which could be taken on the Artemis launch, by looking for lightweight materials that does not conduct heat, which also has the ability to collapse, and implementing a larger quantity of lunar regolith compared to the 550 grams previously used. Thank you so much.